Now it is important for us to understand how spacity works on different masses. So we had this system of molecules in a jar. We tweaked the concept of pressure, and we proved that whenever there is a matter in universe, there is a positive pressure. And the Manthan cycle said that the mandate of spacity is to bring the masses together and act on it. It is important for us now to know how this pressure acts on these molecules. There are various possibilities. The possibilities are, what we have seen here is a theoretical situation wherein all these masses are homogeneous, in the sense every mass is similar to the other. But that is not the situation in case of a universe. We have all these masses which are different, heterogeneous masses. Ultimately, we see that the pressure P is acting on every side of this mass. So this is what we call it as holding pressure. This is the pressure which is ultimately holding the mass in space. How does it act? Let me explain to you. So we had pressure, density, which is kg per cubic meter. Let us consider two cases where the mass is constant and the volume is changing, and the next one is volume is constant, mass is changing. When you consider a larger volume, the mass is same. Let us assume there is a particular density, reduce the volume, come near this mass. Now what happens? The pressure P increases because the volume has decreased. So as you see, once you come near the mass, the pressure keeps increasing, spacity is increasing. It is the highest on the surface of the mass. Now let us see what happens when you keep the volume same and you increase the mass. Volume being same, mass is increasing, that means pressure also will increase as you increase this mass. That is why as you increase the mass, spacity also increases. That is how we see that when you move from moon to earth to Jupiter to sun, it is easier to walk on the moon than on Jupiter, let us say. It is because of the varying pressure, which is related to the density that we have considered. So we call it as a strong force because it is directly proportional to mass. There is nothing else but mass. Now there is another option where we are saying that the spacity, the mandate of the spacity is to bring masses together and act on it. So these could be two static masses, like these two masses. Agreed, the holding pressure is acting on each mass in every direction, but this mandate of spacity is also to bring them together. They could be two, they could be many, they could be static in nature, or they could already be moving. So when you have an external force because of spacity which is bringing them together, we call it as moving pressure. It is weak because it is not just affected by mass but affected by the distance between them, and hence we call the moving pressure as weak. And let us study the next system wherein there are more than two. So this is the new system. As we studied here, the holding pressure is the one which is acting on every mass on the whole surface, and that is acting on every mass of it, but they are static, it has got nothing to do with it. And the next S2 is where these two molecules are being acted upon to bring together. Not just these two molecules, they could be 3, 4, 5 to bring them together and to act on, or they could be in any form that we can put them. But this is all when it is static. So when it is static in nature, so you have S1 and S2 acting. But something strange happens when these masses are moving. We see that most of the times in the universe masses are moving, be it either in the solar system, galaxies themselves, every mass is moving and mostly moving in circular or elliptical fashion. But here we are not saying that spacity is the reason why these are moving in this direction. Spacity S3 that we are talking about is acting post event. There is something else which is making these masses move, which we will study when we come to the stage of how the galaxy is formed from static masses. But for the moment, when it was static, it was easier for space to bring it together so that it can act. But space now has to act on masses which are already in motion. The general tendency of these masses in motion is to fly away from the system because of the inertia, centrifugal force and things like that. Now, we could either consider these masses as equal masses, does not make a difference. Spacity does not make a difference between equal and unequal masses. It acts on all kinds of masses. There could be 3 or multiple masses. They could be in a circular fashion, exact circular fashion, or elliptical, or many circles, because what happens here can happen to the other circle also. But in all this, the mandate of spacity is to hold these masses in motion together and bring them together and then smash. But what is difference between this and this? Here it does not have to worry about the masses going out, whereas here the spacity has to shepherd the masses, in the sense it has to keep them like a flock. It has to shepherd its flocks. So how does that do it? There are 2 ways the spacity could, the S3 could act. Of course, S1 and S2 are acting, they are there. We are now just studying S3. Now, S3 could act in 2 different directions. One, along the masses or against the masses. You will realize when it is acting against the motion of the masses, you will see that all these masses, spacity would be helping them to move away from the system. But that is not the mandate of spacity. It wants to hold them together, shepherd the flock and keep it moving and then bring them together. So the only direction left for it to act is along the direction of motion, and that is how S3 is formed. And as you can see, this is nothing but a cumulative addition of all these small S3s which are acting on each mass, and this is directly proportional to the masses that we consider here.